Then I would like to invite our next speaker on stage, Raul from Off-Chain Labs. There you go. Thank you. And that one. Perfect. Give you a signal in 6 minutes. Then you get two more.
Okay, great. Okay, hello everyone. My name is Raul. I'm an engineer at Off-Chain Labs, the team that is behind the Arbitrum Layer 2. And I'm also a maintainer of the Prism client, which runs Ethereum proof of stake today. So today we'll be talking about Arbitrum Stylus, which is a technology that we recently announced, and it's live on testnet. It allows developers to write Ethereum equivalent smart contracts in some of their favorite programming languages, and basically almost any language that compiles to WebAssembly, which is really exciting. So the EVM is, of course, meant to be small and easy to price. And the bytecode can be fairly small. It looks very transparent. It's simple. But of course, we've had so many developers adopt Solidity as the primary language, despite us having others such as Viper and such others that are coming up, such as Felang. And an unfortunate reality is that, of course, in the past we've seen situations where we would see DeFi hacks almost daily or weekly. And many of these are, of course, a result of the design decisions that came from implementing the EVM. But I'm not here to bash the EVM or say that we need to completely abandon it. Instead, we highly believe that the EVM is here to stay. And we know that the developer experience, the tooling that has been invested over many years, is only going to grow stronger over time. So instead of approaching the problem from the angle of, hey, can we just introduce something completely different, we think about it, how can we give existing Solidity and EVM developers more superpowers? And of course, many projects have introduced alternative VMs, which is, of course, the theme of the summit, many with success, as has been demonstrated, which is awesome. But we believe the network effects are not going away, and there are network effects at many different layers here, right? So there are network effects at the tooling layer, at the application layer, in the actual VM layer, of course, and it's about which ones of these network effects do we want to maintain moving forward. So the question is, to be or not to be? Do we need to abandon it entirely, or can we do something better with the existing EVM? Today, Ethereum is its own little sandbox, kind of, developers have to write in languages that then compile into EVM bytecode. And we're leaving out a huge swath of developers that are already used to many existing programming languages and backend languages. So the answer, the question is, why not both? So introducing Arbitrum Stylus. So Stylus is a next-generation programming environment for Arbitrum chains. It allows developers to write Rust, C, C++, Zig, more, you name it. You can add support for it yourself. It's fully EVM interoperable. And of course, in the EVM, some benchmarks that we have is in the time that the EVM can do 7 single add instructions, with Stylus, we're able to do complete rounds of hashing in a simple hash such as SIP hash. But the benefits don't end there. Because Arbitrum today proves computation over WebAssembly, which is kind of the bytecode that we choose to compile to for many reasons, we ask ourselves the question, can we support execution of WebAssembly smart contracts in addition to EVM bytecode? And we believe that WebAssembly is really a powerful technology that will continue to shape the future. There's a famous quote that we like to look at from Solomon Hykes, the founder of Docker, that said that if WebAssembly and WASI, which is a standard library for WASM, existed back when they were starting Docker, they probably wouldn't have needed to do that at all, which is pretty mind-blowing. So we call this EVM+. So one chain, multiple languages, fully composable, and it's not a new L2. We have one single state transition and one single state tree, which is the Ethereum state tree, one single database, and there is nothing like it. Stylus is much faster. Instead of being interpreted, such as the EVM is in many of the popular Ethereum clients, Stylus leverages some of the existing optimizations that exist for WebAssembly backends using the Wasmer runtime. So we have a 73x faster runtime against Ketchak, for example. And surprisingly, some of the benchmarks around memory shows that Stylus can be 100 to 500x cheaper and more efficient in memory usage, even for medium or smaller size contracts. This slashes fees for users and enables things that just weren't previously possible. Examples are advanced cryptography, precompile research. Instead of waiting many years for Ethereum core devs to ship a new precompile, you can just do it in your own language and get all of that included, and also other heavy computation. What we're most excited about is that you can use the tools you're comfortable with, right? So you don't need to learn a brand new language. You don't need to learn our own DSL of Rust, if you say. Like you can basically do things however you do things today. If you want to access information about the EVM, we provide you with this syscall-like host set of functions, such as say access to storage, calling contracts, and you're able to write basically pure Rust code. And the most important part is that we have EVM equivalence in the sense of how we interoperate with the standards that exist. That means that developers or users could be talking to a smart contract with MetaMask or with their favorite tooling and not know that underneath the hood, it's written in Rust. And that contract is talking to another language that was written in Solidity. And that contract is talking to another one that was written in C. So we have an amazing level of customization and choices for developers to build upon these, their own projects. As an example here, this contract is calling another one, and this is written in Solidity, but the one it's interacting to is in Rust. So there is no extra tooling required. It just works. We believe that EVM compatibility is not the ceiling, but rather the floor. Sorry, I think I messed that up, but anyways. Testnet is live, so you can try out Stylus today for yourself. We have documentation where you can start building, you can deploy some example applications, and really test out how different this is versus writing your own implementations in Solidity. The best part is that you can take existing projects, such as Rust crates or C projects, compile them directly, deploy them on chain, and just basically have that tooling available for you on Arbitrum testnet, which is really exciting. We have first-class support for Rust and C, and because the API to the EVM is so low level, anyone can write a custom framework on top of this. Anyone can write an SDK. It's permissionless. You can do it yourself. Some people started already writing more C SDKs, and there is Zig SDKs as well available for people to use. We also have examples of Ethereum standards, such as ERC20 tokens, that are implemented with Stylus and have EVM equivalents at the storage layer and at the ABI layer. So you're able to interact with them, mint them, transfer them any way you would, and this contract is written in Rust. That means you can see transactions in Etherscan, you can see that it emits the same events that an ERC20 token in Solidity would, and all of that is available to developers right off the bat. If you want to add other programming languages, it's super easy. Adding support for Zig, which is a brand new, relatively brand new language that is aimed to be a successor to C, took me around 16 lines of code. And anyone can do this. So you can even write your contracts in assembly script, or you can do it in a functional programming language, if you will, and you can deploy that to Arbitrum Stylus. And there, the sky is the limit. Do you need something low level? So Stylus provides a very low level entry point, which is just bytes in and bytes out. And you can get started and just go wild. You can do anything you want here. Some examples, there are some benchmarks of showing hyper-optimized smart contracts in Yule, for example, for EVM bytecode, and running a similar non-optimized version of a contract in Rust. And Stylus really does shine the number of iterations and the more expensive the computation becomes. Moreover, Stylus programs can export ABI interfaces that are Solidity equivalent. So in this example, I deployed a BLS signature verification contract in Rust, and I'm able to call it using the Solidity interface, and opens up a ton of opportunities at the application layer that just weren't there before. We also have developer tutorials, so we have a lot of information, and all you have to do is navigate to arbitrum.io/stylus. And here's a capybara. Thank you.
Thanks, Raul. Don't go yet. Don't go yet. Maybe we got some questions. Yes, sir.
Yeah, hey, so very nice. I have a question about metering. So how does metering work on Stylus, essentially? Thank you.
Oh, sorry, can you repeat that?
Metering, like
metering, gas
yes.
metering. Yeah, that's a great question. So a big challenge of dealing with WebAssembly is how do you effectively meter the computation in order for, to appropriately gas price things. So of course, gas metering is different than the EVM gas model. We have done a lot of metering on a lot of benchmarks to better understand how to price each WASM opcode. But Stylus actually does a lot of cross-checking. It does depth checking. It does memory checking. It does stack overflow checking. And we basically walk the contract bytecode that you deploy. We sanitize it, make sure that it matches all those items before it can be deployed on chain. So we have a very strong set of checks, unbounded execution, of course, and we feel confident that this is something that that we have figured out. So. Yeah, and you can look at our metering code and middlewares as well. It's all open source. Yeah.
Any other questions? I could have stayed where I was.
Hi, great presentation. WASM is known to be quite hard to deal with in terms of error handling. I'm curious, like EVM, a lot of reverts happen. Has it been a pain to handle reverts for Stylus, and how did you do it?
Yeah, excellent question. So the nice thing about Stylus is that you can run your Rust code as a normal Rust program, and you can probably inject it with a backend. So you can use some interface. We plan to support things like Foundry, like Forge, and Ganache, and things like this. So from there, you'll be able to easily do that. So you can run it as a native binary, or you can run it as a WASM binary. It's really helpful to run in native mode for debugging, but in WASM, if you use the Stylus SDK, we support the Solidity ABI model, we support Solidity storage types and everything, so reverts and execution debugging will be very similar to your Solidity debugging experience. And we hope that with tools like Foundry, you'll be able to just debug it like you would any normal smart contract.
Yeah. So, quick question. So this would still work with Solidity-based proxies, right? I would be able to deploy this and point my regular, let's say, Diamond proxy to use this as a facet, right?
Yes, that is correct. That's a very exciting use case. So you can swap out something that's in Solidity and upgrade that to a Rust contract, and it will be equivalent.
And I got one more question for you.
Sure, yeah.
Hey, it's me again. Can you hear me well?
Yes.
Yes. So I'm also wondering about standard library support, like for example in Rust. Can you code using the standard library, or would you need in Rust to use no STD or something like that?
Yes, you can use the standard library. Of course, you can't use things that are non-deterministic. You can't. Floating point support is coming, so that's going to be a big thing. And yes, you can use the standard library. You can use it with no standard library, which is really exciting. Something that we think is really powerful is that somebody could deploy the Rust standard library as a standalone thing to Arbitrum Stylus, and then programs could link against it, kind of like how they, how we do dynamic linking and linking in general in the Solidity ABI model. So. That's a possibility for sure.
All right. Thank you, Raul.
Thank you.
Thanks, man.